Okay guys, so for this video, I will explain the answer for our first formative assessment, which is about using and manipulating surds. Okay, let's just go to the first question here. We have simplify this expression over here. Now, when you see like surds that being added, right, if you don't see that they have the same surds, what I mean the same surds, for example, like 2 square root of 3 plus let's say is 5 square root of 3, can you see that both of them are square root of 3? It means that they have the same surd, right? Yeah, you can actually, when you add or subtract again, make sure that you have the same surd first. Now, if in the case you don't have the same surd, you might want to like simplify them first. For example, like this square root of 27, can we write that here? The square root of 27 actually can be written as the square root of 9 times 3. Now, the reason why we need to do this because we need to figure out whether we can pull out a number or not. Now, remember that if we have a multiplication or division, you can actually split this two. That will be like this, and you see that this guy, right, the square root of 9 is just 3, right? So you see like 3 times square root of 3, there'll be just 3 square root of 3. Okay, so this is just one example. Now we have to do everything here so that, and figure out whether they will have the same surd or not, right? Okay, now let's see it one by one. Okay, so the square root of 27 we can actually write down like that. I'm just gonna erase this, and I'm gonna just write down here that square root of 27 becomes the multiplication of 9 times 3, and the same goes here, right? Plus square root of. Now when you pick the two numbers, one of them, at least one of them, should be a perfect square. Now you might want to think this is like also 6 times 2, right? 6 times 2 is also equals to 12, but you see that none of these two numbers are a perfect square, right? So you can't have like the square root being pulled out, yeah, into becoming not a surd anymore. So instead, we're going to use 4 and 3, yeah, because 4 is a perfect square. Okay, the last one, we don't need to do anything about it. Just write down square root of 3. And you see that here we have square root of 9, which is just 3. So this can be written as 3 square root of 3. And the square root of 4 is 2. So you'll get 2 square root of 3. Then again, the square root of 3 here, you can't pull it out. So it stays inside the surd. Yeah. And then minus square root of 3. Can you see that all of these terms have the same exact surd form, which is that square root of t, square root of 3. So again, we see that this is minus square root of 3. It means that it's minus 1 square root of 3, right? So remember in algebra, it's just like the same thing, like 3x plus 2x minus 1x, right? So you only need to add or subtract the coefficient, like 3 plus 2 minus 1, right? And then you get the final answer. But don't forget, you still have that square root of 3, yeah? And that'll be equals to 3 plus 2, which is 5. 5 minus 1 is equals to 4. So the final answer is 4 square root of 3. So don't forget that square root of 3 still on that number. Okay, for the second question, 1b is actually the same thing like before, right? So you can actually write this 72 as 36 times 2, this one, right? The square root of 98 will be 49 times 2. And again, guys, when you pick this, just remember that at least one of them should be a perfect square. 36 is a perfect square. 49 is also a perfect square. And the same thing here, the perfect square that we're going to use is 25. That will be 25 times 2. And this one is going to be 9 times 2. And again, everything is like multiply by 2, right? So we can actually simplify it again, guys, like before. We know that the square root of 36 is 6, so this will become 6 square root of 2. So this guy becomes this guy. Again, that will be inside the square root. That's why it's outside the square root. And this becomes 7 square root of 2. And this becomes 5 square root of 2, and the last one becomes 3 square root of 2. Then again, now we have all of the surds in the same form, which is the square root of 2. Now again, this is like the same thing, like 6x minus 7x plus 5x minus 3x, right? Pretty simple. Now let's add them together. For example, let's say we have 6 minus 7, there will be minus 1. Minus 1 plus 5, there will be 4. 4 minus 3 is just equals to 1. So the final answer should be 1 square root of 2, or you don't need to write down the 1 because you don't really need to. Because for example, like x, this is actually 1x, but you don't write down the 1, right? So it's just square root of 2. Okay, for number 2, this is pretty simple. Since you know already how to open brackets, right? So you only need to multiply the square root of 2 with the 3 and with the negative square root of 5. So this is pretty easy. Now if you multiply square root of 2 times 3, and then we have square root of 2 times negative square root of 5, there'll be something like this. Negative square root of 2 multiplied by square root of 5. Can you see that if you see that this is one third is one is not, right? So you only need to rewrite them and just write down the number that is not a third in front of that third. There'll be 3 square root of 2. And for this one here, again, the same thing like we did over here, right? So it's like doing the reverse operation, like moving that inside. I mean, like you multiply the one inside the third with the one inside the third. Can you see that you can actually just write down as like 2 times 5 inside the third, which is just equals to 10. So this will be square root of 10. Okay, pretty simple. Now the next thing, the next question is 2b. It's actually almost the same thing, but we know that we need to do the FOIL method, right? Or the FOIL, what do you call it? The rainbow method, right? 1, 2, 3, and 4. Because again, you're multiplying here. Don't forget that you need to make sure that it's being multiplied, not being added or subtracted. Yeah. So let's do it one by one. The square root of 3 times 2 is the same thing like we did over here, right? So I'm just gonna write that down as 2 square root of 3. So the 2 is outside, I mean like in front of the square root. That's this one. And the next one is we're gonna multiply this with this, which is going to be just 3, because we know that square root of 3 times square root of 3 is square root of 9, which is just 3. And we know that square root of 3 being squared is just 3. Yeah. So I'm gonna write down, don't forget this is going to be minus, right? So it's minus 3 because you're multiplying positive with negative. And then the next one is 2 times 2, which is just 4 plus 4, and the last one is 2 times negative square root of 3. There'll be negative 2 square root of 3. Then again, you see that if you want to combine them, so know that this you can combine it with this, right? Negative 3 plus 4 is just equals to 1. And the surds also the same thing. Here again, you see that the same surds, right? So it's just subtracting those two, you'll get equals to 0, right? Because this minus this is equals to 0. And this is just equals to 1. So that'll be just equals to 1. Question number 3, you're being told to rationalize the denominator. It means that if you see that we have a fraction in which the denominator is a third form like this or this, right? So we have that third over here, right? It means that you need to get rid of the thirds on the denominator, only that. Yeah, the one on the numerator, it doesn't matter. Now, the way we do this, if you have like a single term like this, I mean like if it's just like square root of something, or you don't have any like plus or minus like this, it's pretty easy. You only need to multiply that fraction with the denominator itself, right? So you multiply. Okay, let's go to question A. So question A is just like 2 plus square root of 5 over square root of 5. You multiply this with square root of 5 over square root of 5. But you see that it's just multiplying by 1, right? Anything multiplied by 1 goes back to the original number, right? So, and can you see that if I multiply square root of 5 times square root of 5, they'll be just equals to 5, isn't it, right? Okay, now the way we do, again, multiply this, be very careful that you need to multiply this with this. Now, you might want to like put some brackets if you want to do it one by one. I'm going to put like this, 2 plus square root of 5, and then multiply by square root of 5. The one on the denominator is just like square root of 25, which is just equals to 5. Right, and again, remember that when you multiply this, you need to do it like this. Yeah, you need to distribute this guy to each of them. Yeah. Okay, now let's do the same thing like before. If I multiply 2 with square root of 5, it's just 2 square root of 5, right? And equals to 2 square root of 5. And then square root of 5 times square root of 5 is just 5, right? And then plus 5. Don't forget the plus because this is an addition. And then over 5. And that's it. Okay, now be careful that you cannot do this. Okay, that's what we call an illegal canceling. Yeah, because if I have, for example, if like 2 plus 3 over 7, the concept is that both of these two numbers should be divided by the same denominator. So I should write it down like this. Yeah, so you cannot cancel. For example, if I have like 6 over here, you can't cancel this becomes 2 because they should be, both of them should be divided by the same number. Yeah, okay, so be careful with that, with the illegal canceling. Okay, question B, we have that square root of 7 plus 2 over square root of 7 minus 2. Now, if we have something like this in which the denominator is not a single third, like before, like this one over here is just like a single one, and you're like being added or being subtracted by something else, you need to multiply this by the conjugate, the pair of conjugate of the denominator. Now, the reason why we do that, because if I multiply conjugates, yeah, the pair of conjugate, they'll be just like the difference of the square of both of these two numbers, right? The first number being square and then minus the second number being square. Now, if you square a square root, the square root is gone. That's why we need this concept to be able to get rid of the surds on the denominator. Now, if we do that, let's just multiply that. multiplied by the conjugate of this is just like changing this sign over here. So if it's minus, then the pair of conjugate is plus. Yeah, if it's plus, you're gonna be minus. So you don't really need to pay attention with this one for now when you want to get rid of the surds on the denominator. So you multiply this with square root of 7 plus 2. Can you see that? It's like minus becomes plus, and then over square root of 7 plus 2, right? And then you do the same thing like before, like this one here. You see that for this question over here, right? You can do it like this, okay? And then yeah, we could just like do that. Let's just try it. Wait a minute. Okay, so if we multiply this, remember that you should only if you want to like rewrite them again, you should write it down like this: square root of 7 plus 2, and then square root of 7 plus 2 from here and here. Maybe I'm just gonna copy paste them so that you can see it easily. Okay, I'm gonna use the lasso tool. I'm just gonna like combine this. I'm gonna like this one over here, and then just like copy them and then paste it and put it here. Okay, so and then square of 7, okay, and then you put brackets. So this is very important because you're multiplying, right? The same thing goes with the denominator. It's just like square of 7 minus 2, and then bring bracket, and then multiply by square of 7 plus 2. Now from our previous my previous explanation about conjugates, if you multiply pair of conjugate, it's just the difference. The result will be just the difference between the first number with the second number. I mean, like the first number being squared and then the second number being squared, right? So you notice that the square of 7 is just 7, right? So that'll be just 7. If you square this, it's just 7. If you square this, you get 4, right? So on the denominator now, it's just 7 minus 4. Okay, on the top, yeah, on the numerator, you have to do it like before, like this, and this, and then this, and then this. Okay, let's do that again. So that'll be square root of 7 times square root of 7 is just 7, and then plus 2 square root of 7, and then another plus 2 square root of 7, and the last one is 2 times 2, which is equals to 4. Now, because we already learned how to simplify, we see that we have 7 and 4. If you add them, you get 11, right? 11, and then 2 square root of 7 plus 2 square root of 7, that'll be 4 square root of 7. And then 1 on the numerator is just 7 minus 4, which is just equals to 3. Can you see that this is like the simple form? You can't like really change the fraction because both of these two numbers are not divisible by 3, for example. So this is going to be the final answer. Okay, for number 4, express this in the form of a plus b square root of 6, where a and b are integers. Okay, now you see that this is like a fraction, and you will later on get a result or a simplification form in which don't have any fraction anymore, right? So which means that you might want to do it like this, yeah, like we did for number 3b. So you're just like, you need to like remove the surds on the denominator, right? And then by multiplying that by the conjugates, the pair of conjugates. Again, guys, when you have this, you need to have the same number on the top and the bottom here because they're basically just equals to 1, right? So in here, the one that you need to pay attention is just the denominator, right? So the denominator is 5 square root of 2 minus 4 square root of 3, which means that the pair of conjugate of that is just like this guy plus this guy, right? You see that? Just doing it like that. So okay, let's just write down again. So we have 7 square root of 2 minus 6 square root of 3, and then over 5 square root of 2 minus 4 square root of 3, and then multiply by the pair of conjugate of this guy over here. There'll be 5 square root of 2 plus. So you see that this is minus, this is going to be plus. Yeah, it's the opposite operation. Yeah, 4 square root of 3 over 5 square root of 2 plus 4 square root of 3, and the rest is actually the same thing like we did over here. So but just like the numbers are like pretty big, but you can actually do it within using your calculator. Yeah, so I'm gonna just skip a couple of process here, and you can see it later. Okay, see that the process here, I mean, like it's just the same thing like before, right? So when we have like all of the things over here, it's actually just like multiplying one by one. That's right, this times this, it'll be like 7 times 5 is 35, and then square root of 2 times square root of 2 is just equals to 2, right? So I'm basically doing all of the calculation here. You can actually do it by yourself, and you see that in here on the bottom here, the denominator, we use that a plus b times a minus b they'll be equal to the first number being squared and the second number being squared. Here, the first number is this, you square it, right? And then the second number is going to be this, and then you square it. And then always you're going to have a minus because you're multiplying one negative with positive. So that's why the last one here is going to be negative. Okay, let's do the next calculation. Okay, so here we're just like adding all them up. Remember that we can actually add this and this because they are like terms. They have the same surd, and that'll be this guy over here, right? And then for the next session, the next one here, we have this one is 25 from 5 being square. We have this 2 from square root of 2 being square, and so on. Yeah, and you see that if we add them up, you will get something like this over 50 minus yeah, it's 50 minus 48, which is equals to 2. And you see that this is not the simplest form because you see that every single of these terms are divisible by 2. Now, you can actually do it like this. If you want to like factorize this, you can pull out the 2, right? There'll be 2 bracket minus 1 minus square root of 6, right? For this one over here. And we have over 2, and then we can cancel out the 2, right? So which means that the final answer should be minus 1 minus square root of 6. Let's go to the last number here, number 5. There's a couple of ways and a different way in how to solve this kind of question. It depends on your perspective. Sometimes my method is different with other teachers' method. Maybe with your method it's fine. But it's fine as long as you write it down systematically and we know the logic and how you get the answer. Okay. So let's read the question here. We have a right angle triangle with lengths of the legs are these two, and we have the area, which is this one over here. Now, whenever you see like a context problem like this, you might want to like read the question very carefully and then try to identify what you have from the question. Here you have the legs, and then we have the figure here. This is like the base and the height, right? So the base and the height over here. And then we also have the area which is over here. Now, what you need to do first is to connect all of the information that you have from the question and then try to answer the question. Now, we know that if we're talking about area of a triangle, you know that we have a formula, right? So the formula of the area of a triangle is equals to base times height. I'm going to write down base times height divided by 2, isn't it, right? And then to determine the base and height, those two lines should always be perpendicular. Can you see that this is like 90 degree? That'll be perpendicular. It means that we can choose this as the base and the height. It doesn't matter this is the base or the height, or this is the base and the height. Yeah, it doesn't matter, because if you multiply, you will get the same exact result. Yeah. So let's say this is the base. I'm going to say this is the base and this is the height. So what you need to do next is like plugging every single of the value into the formula. See the area, which is in green, and we have the base, which is wait a minute, it's the height. Okay, this one here, the yellow one, and then the last one is going to be the base, which is that sorry, should be the blue one over here, right? See, you only need to plug it in. Okay, let's plug in everything. Okay, here we go. Now, again, you only need to plug in every single of these numbers here into the variables, right? And you see that this is like just like a algebra equation in which you can actually solve it by yourself, right? Just manipulate, like multiply everything, like expand the bracket, and then you see if you have the x, it's just like go for the x, yeah? Okay, now let's do it again, guys. Let's just continue this. Now, if you see an algebra equation in which you have a denominator of a fraction, like this one over here, I don't really like fraction. I don't like this. Now you might want to like get rid of that 2 first. Yeah. So how do you do that? You just multiply everything by 2. See, if you multiply this by 2, it's gone. So whatever you do on the left side of the equal sign, you need to do the same thing on the right side of the equal sign. Okay. So I'm gonna just like move this again a little bit to here so that you can actually see it. Here we go. Okay. Now, if you do that, multiply right side of with negative with 2, you also need to multiply this by 2. But be very careful that you need to put brackets here. Okay. So if you multiply it like this, right, you will get 2 square root of 3 over here, and then plus 34. They'll be equal to, right? The 2 is gone here, so you only need to do the FOIL method, right? So that and that, and then this and this. Yeah. Okay, let's do that. I'm gonna put the first one. There'll be 3 square root of 3 times x square root of 3, right? And there'll be just 9 square root of 3 of x, isn't it? Sorry, it's 9x. Sorry, my bad. It's 3 square root of 3 times x square root of 3. And you see that if I multiply this with this, you get 3, and then multiply by this, you get 9. Yeah, so it's just 9x. Okay, that's the first one, 9x. The next one is multiply this with this. There'll be just 6 Yeah, plus 6 square root of 3, plus 6 square root of 3. And then you can multiply this with this. It'll be minus x square root of 3. And then the next one, you can actually multiply the negative 1 and 2, which is just negative 2. Okay, and we're done for the second line. Can you see that now we don't have any fraction anymore, right? Okay, now the next thing we do is we can actually move everything to one side. For example, I'm going to move this 6 square root of 3 and this 2 to the left side because it does not consist of x, yeah? Now, because again, we need to isolate so that the x is alone, yeah, on one side. So if we move that, you will get 2 square root of 3 plus 34. This guy becomes minus 6 square root of 3, yeah? And then this guy here will become plus 2 equals to 9x minus x square root of 3. And then if you see that, you can actually just like rearrange that. I'm gonna just like add the rational number first, which are these and this. That'll be 36. I'm gonna put that 36. And then if you add the other guy, the one that has the square root of 3, this guy and this guy, there'll be minus 4 square root of x. Sorry, minus 4 square root of 3. Minus 4 square root of 3. And then that will be equals to 9x minus x squared root of 3. Now, if you see the form of the expression on the left side and the right side, you can actually see that you can just actually just match them. Like this guy is this guy, right? Because those two does not have any square root of 3, and you can actually see that also that this guy is actually this guy. See? Now, if you match it up, if you don't want to like do a like more calculation, you can actually say, oh, it means that 36 is equals to 9x, right? So if you do that, you can say, oh, if I have 9x equals to 36, and x will be just 36 divided by 9, which is just equals to 4. And the same thing if you go here, right? See? This one here, we take that, negative 4 square root of 3 is equals to negative x square root of 3. Can you see that the square of 3 is gone now? And then you can actually cancel the negative. So you see that the 4 will be equals to x. And you will get the same exact number. But if you decided, for example, oh, I want to like isolate the x one by one, you can actually continue this process. Now, how do you do that? You see that this one too, you can actually pull out the x, right? So I'm going to write down here, there'll be that 36 minus 4 square root of 3 is not done yet. But this one here, you're going to factorize so that the x is going to be outside, yeah? It'll be x bracket 9 minus square root of 3, right? Right, 9 minus square root of 3. That's it. Okay, now the next part is you only need to divide this by this, isn't it? Right, so if I move that to the left side, there'll be 36 minus 4 square root of 3 over all of these, which is 9 minus square root of 3 equals to x. Now you can actually calculate this, but you see that this one here, all of them are divisible by 4, right? So why don't we just like pull out the 4? So for this one, if you factorize, you get 4 bracket 9 minus square root of 3, and then over 9 minus square root of 3. And again, you see that this is the same thing, so you can actually cancel this, right? Because again, they are being multiplied. This is like 1 times this, right? They'll be equals to x, and you will get the same exact result, which is 4 over 1, which is just equals to 4. Okay, so again, no matter what method you choose, yeah, just choose the most convenient for you to use during the test, yeah, because again, you can actually use the calculator later on in the unit test, so the use of calculator will be very beneficial for you guys. So I recommend that you always also practice on how to use the calculator. Yeah, okay, so that's it.